All right, let's talk about AI hardware. It's one of those topics that can feel super overwhelming, right? But I promise we're going to break it all down. By the end of this, you'll have a really simple framework to help you make the right choice. Let's dive in.
Because it's not just about getting your AI project to run, it's about making it fly. The right hardware is the difference between an AI that feels like pure magic and one that just, well, kind of crawls along. So, first question. You probably have a powerful laptop. So why can't that fancy CPU inside just handle all this AI stuff? Well, it all comes down to the kind of work AI is actually doing. It's just a completely different kind of thinking.
Think of it like this. Your normal CPU, it's like a brilliant specialist, a math genius. You can give it one really complex problem and bam, it'll solve it incredibly fast. But AI is different. It needs to do millions, sometimes billions, of very simple calculations, but all at the exact same time. It's not a single genius, it's a massive army, and every soldier has to march in perfect sync. Your CPU just wasn't built to command that kind of army.
And that's where this specialized hardware comes into play. For AI, I like to think of it as the hardware trinity. You've got three main types of processors, and each one has its own special superpower. So let's meet them.
These analogies are just perfect for understanding the roles here. First, you've got the GPU. And yeah, NVIDIA pretty much dominates this space. It's the Swiss Army knife of AI. It can do almost anything you throw at it and do it pretty darn well. Then there's the TPU. This is Google's baby, and it's a straight-up F1 racing engine. It is hyper-specialized for one thing, training enormous models in the cloud at blistering speeds. And finally, the NPU. This little guy is probably in your phone or your new laptop. Think of it like a pocket translator. It's incredibly efficient at one specific task, which is running an AI model that's already been trained. For most of us building stuff at home, we're going to be living in that GPU world.
Okay, so you know you probably need a GPU, but you go to look for one and you're just hit with this wall of specs. Cores, clock speeds, all this stuff. Let me simplify it all for you. Before you look at anything else, there's one number that matters more than all the others combined.
And that number is VRAM. Here's the best way to think about it. VRAM is your workbench. The AI model is your project. And here's the rule. To work on the project, the entire thing has to fit on the workbench all at once. Every single part. If your project is even a tiny bit bigger than your bench, you can't even start. It doesn't matter how fast you are. If it doesn't fit, it doesn't run. Period.
So this brings us to the big question, right? How much space do these projects actually take up? Just how much VRAM are we talking about here? And the answer, well, it might surprise you. We are not building small little model kits here. We're talking about assembling industrial-sized machinery.
And this chart just lays out the challenge perfectly. A relatively small 7 billion parameter model, that needs about 14 gigabytes of VRAM. Okay, but a bigger, more capable 70 billion parameter model, whoa, a staggering 140 gigabytes. To give you some perspective, the best consumer graphics card you can buy today tops out at 24 gigs. So, it seems impossible, right?
Well, it would be impossible. Except the AI community came up with this incredibly clever trick to make those massive projects fit onto our more modest workbenches. And that trick is called quantization. Honestly, it's a simple idea. It's basically just rounding numbers. Instead of using a super precise number like 3.14159, you might just use 3.14. It's a little less accurate, sure, but it takes up way less space to write down. Quantization does the exact same thing to the billions of numbers inside an AI model, and that shrinks its size dramatically, usually with only a tiny little hit to its performance.
And the impact is just stunning. That 70 billion parameter model that needed an impossible 140 gigs of VRAM. After you apply 4-bit quantization, it suddenly only needs around 35 gigs. Now that's still a lot, but it's a number that's actually in the ballpark for high-end consumer hardware. This one technique is really what makes running powerful AI at home even possible.
So this all leads to the big practical decision that every builder has to make. Do you invest in your own powerful hardware to run AI on your own machine, or do you basically rent a supercomputer in the cloud? And there are definitely trade-offs. Running locally gives you total privacy and control. Your data never leaves your computer. It's a one-time cost, but you are limited by the power of whatever you can afford. The cloud, on the other hand, gives you access to almost unlimited power, and you only pay for what you use. The downsides? Those costs can really add up, and, you have to be comfortable sending your data to someone else's servers. There's no single right answer here. It all depends on your project.
Okay, so let's put this all together. With everything we've just learned, how do you actually go about choosing the right hardware? Well, it all boils down to one simple rule.
This right here is the golden rule. If you take away only one thing, make it this: VRAM first, then speed. A slightly slower card that has enough VRAM is infinitely better than a lightning-fast card with too little. Just remember the workbench. If the project doesn't fit, you can't work on it at all.
So here it is, your action plan, in 3 simple steps. Step 1, know what model you want to run. How many billion parameters does it have? Step 2, calculate the VRAM you'll need after quantization. A good rule of thumb for a 4-bit model is just taking the parameter count and dividing by 2. So a 7dB model needs about 35 gigs. And step 3, go buy hardware that meets or even better exceeds that VRAM number. It really is that simple.
So there you have it. The whole world of AI hardware, which seems so complicated, really just breaks down to that one key thing: get enough VRAM. The power to run these incredible AI models is more accessible today than it has ever been before. So the only real question left is, what are you going to build with it?